Hello, everybody. Welcome to Unit 5, Lesson 2. Okay, we are going to talk about conditional probabilities. And as far as seeing this on the finals, Unit 5, Lesson 1, not so much. Maybe the equation that you need to find, like A or B. Remember, that's A plus whatever B is minus A and B. That might come into play, okay? That might come into play. You're not going to see the probability of one event. That I would be shocked. But this conditional probability shows its ugly face every once in a while. And I say ugly, it's really cute little probability there, okay? It's important to know you might see conditional probability in the finals, maybe. But more importantly, when we move forward from Lesson 2 into Lesson 3, we are going to talk about independence. Independence versus independence versus dependent. Okay, events and probabilities. And you need to know conditional probabilities for that. Okay, there's always one question that has to do with probabilities and independence. Okay, so this is a good building block for that. So I've talked enough. Let us move forward, shall we? By the way, I can never get enough of hearing myself talk. To be a teacher, you got to have a godlike complex where you think you know everything even though you don't, and you think everybody wants to hear your voice even though they don't. Okay, so let's start here. Calculating conditional probabilities. There is one big word, and I don't mean it's a long word. It's really only 5 letters. But there is one big tell. Whenever they're asking for a conditional probability, that is the word given. Okay? Anytime they say the probability of A given B, all right, that means conditional probabilities. And I can spew off all these, important pieces of information, but I will wait till we actually start doing some of the math, because that seems to be the way that students really grip it. And I will give you said pieces of information as we are doing this math. And you will hear me use the word given a lot. Okay? So let's jump right in. Example 1. In this study, 52 graduating high school seniors were surveyed as to their post-graduation plans, and their results were recorded by gender. Okay, so if I'm looking at this table and just do a quick little glance, here are all the males. Okay, there's a total of 30. Here are all the females. There's a total of 22. Here are all the people going to college, and there are a total of 29. And here are all the people not going to college. There are a total of 23. And as the problem first states, this is my overall total. Okay, the bottom right corner. They interviewed 52 graduating high school seniors. All right, good. I like what I see. I can make sense of anything in this table. All right, except the fact that there are 23 out of 29 that are not going to college. Education is important, kids. Now, let's take a look at what else they give us down here. All right, they say, okay, M, when we start doing probabilities, M means male. Okay, C, going to college. F is female, and N is not going to college. So let's start taking probabilities based on our table above here. So A, okay, if a person is picked at random, find the probability that they are female. All right, well, here are all my females, and there are a total of 22 females out of the 52 they surveyed. So that's my probability. I'm not going to have you put that into a decimal. If I did, I'm fairly confident you could put 22, hit the division button, and then put 52 in the calculator, and then hit enter. Okay, if you want to go nuts, I'm going to say 22 out of 52. That's fine. Okay, let's look at B. The probability that this person that you pick at random is going to college. Here's going to college. 29 total people out of my 52 are going to college. Okay? Not bad. This is easy. Really, A, B, and C, and D are reviews of Unit 5, Lesson 1. When we get to the fifth one, E, that's going to be the given. Okay, so let's look at C, the probability that they are both male and going to college in our table. All right, if I pick one person, what is the probability that one person is both a male and going to college? So, it is time for my favorite part, highlighters. These are the males. There are 30 of them. Okay? These are the people going to college. There are 29 of them. I don't care if there's 30 males and 29 that are going to college. I care about the people that are listed as both. The number 16 is both male and going to college. So 16 out of my total 52 would be the probability of selecting an individual who is both male and going to college. All right. D, the probability of female or going to college. Oh boy. So, and I'm going to do this over here. Let's remember the probability of female or going to college. Disregard what that looks like in the parentheses. Okay, because every lesson someone says something. Okay, that means I need the probability of female plus the probability of going to college minus the probability of female and going to college. Okay, I need all three of those pieces, and that's going to give me the probability of female or going to college. So let's clean this up a little bit. Put this back down here. And let's take a look. So the probability that we have a female is, these are all my females. There's 22 of them. So right here, 22. Plus, the probability that someone is going to college is right here. It's 29. Okay, plus my 29 minus, okay, minus both. What is the only number that is both female and going to college? 13 is female and going to college. Minus my 13. This would be 51 minus 13, which would be 38. We don't want the number, we want the probability. 38 out of my total 52 are either female or going to college. All right? Not too shabby. That is a review. Okay, I'm going to erase this work. No, let me highlight this first, okay? So all this stuff right here, review from Unit 5, Lesson 1. Okay? And if anything that might be relevant on the test, you might need to know, oh yeah, that's bad. You might need to know that the or is this right here. That might come into play. All right? So let's start to look at given. Erase. I like to erase. Now, it says the probability, okay, let's use black here. The probability that someone is going to college given female. Let me explain given right this second, okay? And in fact, that's weird. What's happening there? That's how that's. I don't know what's. It's crunching together. Weird. So let's just do this. Put it back. Let's scroll this back up, and let's get rid of some of this, okay? And I'm going to rewrite what they're asking us right here. The probability they're going to college given female, okay? I only know one obvious way to explain this so that it sticks in your brain, okay? Whatever we are given, typically, listen green, this is out of 52 people. Anything we do is out of 52. Notice our previous responses to our probabilities for A through D. Okay, female, out of 52. College, out of 52. Male and going to college, well, it's 16 out of 52 because look, there's 52. And what else do we have here? Female or going to college, 38 out of 52 because every one of those probabilities was taken when you were considering everybody interviewed, all 52 people. This is not the case for given. We are only given the females to choose from, okay? So we are given the F, which is female, to choose from, okay? That becomes our new denominator, if you will. Okay, so right now, where are my females? Let's go pink for females here, okay? Right here. These are all the females. There are a total of 22 females. So right at this very moment, I don't care about anything else because I am only given females. This is what I'm given to choose out of. There are 22 females to pick from. If that's what I'm given, if I am only given females, that means my answer is going to be out of 22 because that is the pool of individuals that I am given to choose from. Okay? Whatever they give to you to pick from, that's it. I no longer have males to pick from. I don't have these 30 people here to pick from. Yeah, you can't see that. I don't have these 30 males to pick from. Bye-bye. They gave me females. That means I only have out of 22. I have a choice out of 22. Okay? Now, what do they want to know out of the female population here? Which females are going to college? Okay? These are the ones going to college. These are the ones not going to college. I don't want these, do I? 13 out of my 22 females are going to college. Okay, so I'm going to call that 13 out of 22. I told you I was going to use the word given a lot. Okay, given. There you go. It's one more. So, really, really important. Whatever they give you, in this case it's females, that's the only thing that matters. I'm given. My probability should be out of this 22 right here. All right, so let's erase all this poo-poo, and let's do something else now. Let me show you one more thing when it comes to this. Okay, scroll down here. So, we just figured this out right here. Okay, college given females. That's 13 out of 22. Well, does that equal the probability of females given college? Notice I switched these two groups, okay? Here I had the C first, then the F. Here I'm putting the F first, then the C. You say, oh, it should be the same thing. No, because we're given a different pool to pick from. I am given college to pick from. Nothing else matters. Let me go back here. Okay, so now I'm doing, again, what's up with the movement there? Boom. Going back here, now I am asked to take the probability of females given college. This is the only thing that matters. I don't care about these 52, okay? Going to college. These 29 people, so this should be out of 29 because that's what I'm given. Nothing else matters. I don't care about the people not going to college. I don't care about those 23 people, okay? I mean, I do. I'm sure they're nice people. I'm sure they're going to go on to achieve great things. But for this problem, okay, how many are females out of all the group going to college? All right, well, here's all the group going to college. These are the males. I don't want them. These are the females that are going to college. So it is 13 out of 29. So when I come back down here, this is 13 out of 29. Are they the same? No. So does P of C given F equal P, the probability of F given C? No, it doesn't. All right? So be careful. Don't think because you found one that you can switch the letters and it will be the same. I mean, maybe it would. Maybe it would be coincidentally be the same, but that is not a rule. It does not apply. Don't think because you know one, you automatically know the other. You do not. So let's take a look at an example that, doesn't have a table. So there's a second way we can use to find given or conditional probability. Let me take a swig of this water. Normally it's coffee, but this is an afternoon. It's rare that I've got the opportunity to record a video in the afternoon. My school has their prom tonight, and all the juniors and seniors left at 10 o'clock to go get their hair did and their nails did, and they're going to look fancy. And I'm going to prom. I'm going to chaperone it. I'm going to be one of the chaperones. I can't wait, but right now would be calculus class, so I'm in the room where my calculus class is, and let me show you how many kids are in here for calculus. Hey, if you're in here for calculus, scream. Wait, I don't think they heard you. Scream. No, you didn't hear them because no one's here. Every single senior that's in my calculus class is going and getting prepped and looking pretty tonight. All right, so I actually have time in the afternoon, no coffee, water. Fine, let's do example 2. Historically, a given day at the beginning of March in upstate New York, weather sucks, has an 18% chance of snow. Okay, this seems familiar. Seems like it's going to be important. 18% chance of snow. And it has a 12% chance of rain. All right? If there is a 4% chance that it will snow and rain on a day, then calculate the probability of each of the following. All right. I don't have a table to look at. I can't cross off everything I know, everything I don't know. So there's another small equation that we can use to to calculate conditional probability. And that conditional probability, I know because it says given here. All right? So the probability of rain given snow, bam, there it is. I'm not so concerned about this bottom here, okay? If they happen to give you whole numbers, that's what this bottom thing is for. I'm more concerned about the top, all right? The probability of A given B, okay? Obviously, we only get to choose out of B, right? So my bottom, my denominator is just what I'm given to choose. It's still B. But the top, you take the probability of A and B, and you divide it by the probability of B, the second one, okay? The second one. So let's apply that to this, what they're telling us to do for A here, okay? This A. So the probability of rain, I'm going to use an R, given that it snows, all right? So you are going to see, and I like to just a little side note here. This means and. I know that because I can make a capital A here. I will show that to you in a second. This means or. And is both, or means one, or maybe two. You only need one or the other. This bar means given, and you might see me start to use this bar, okay, and I will use it here. This is all probability notation, okay, so I know this top left one here is and because it's the only one I can make an A out of, capital A, boom. A is for and. This is or because, well, it's not and, okay. And this means given. So, right back here, the probability that it rains given snows, okay? That's the probability of both, okay? Oh, another highlighter opportunity. The probability of both over the probability of the latter one, okay? Because that's what we're given to choose from. So let's do this. It's the probability of rain and snow all over the probability of just snow because that's what I'm given. So rain and snow, that's this 4% right here. 4% is rain and snow. So I'm going to write that as 0.04 divided by the probability of just snow, okay, 18% chance snow. So that's 0.18. Yeah, I know I like fractions, but please, when you have a decimal over a decimal, like, clean that up. We really don't like decimals in fractions. Decimals can be represented as fractions themselves. And I don't like to have fractions in fractions if I can avoid it. In calculus, you might. Let's just turn, come on, there you go. So let's do this. We got 0.04 divided by 0.18. I hit enter, and that is a repeating deuce, 0.22222. I will just call that 0.22. There is a 22% chance that it will rain given it snows. All right, let's look at part B. Okay, the probability that it snows given it rains. All right, so now, again, we switch these, and we just learned they are not necessarily equal. Okay, it's not just an automatic. Oh, we already have that, it's 0.22. No, they're not the same. Maybe it comes out to be the same. Maybe there will be a coincidence, but chances are it will not. But let's check it out anyways. The probability that it snows, okay, given it rains. So let's do this in red. Okay, the probability that it snows given it rains equals the probability of snow and rain all over the second one that I'm given, just the probability of rain. All right, and let's clean some room up here. Let's clean this up and get some room. You know, we need to work. We got big brains. We need a lot of room. So let's take a look at this. What do we got? What is the probability of rain and snow? Well, we already have that. 4% is rain and snow. Okay, so when it comes to and, order doesn't matter when it comes to and. So that's 0.04 over. But now, what's the probability that it rains? Rain. Oh, I wanted that in red. Again, what's up with the board, baby? All right. So rain is 12%. All right. So 0.12. Well, I know 4 goes into 12 3 times, so 1/3, which is 0.33. If you put this in the calculator, you would absolutely get that. And they are not the same. And that's fine. They're not supposed to be the same. Maybe they are. Maybe there's a slim chance they are. But it is not given. I shouldn't say given. It's not an equation. It's not a rule that they are the same. So those aren't supposed to be the same. Okay, so we looked at a table for example 1. That was cool. That was easy. We looked at a word problem that gave us numbers for example 2. And you know what? With that kind of little, the probability of A and B over the probability of B, that really wasn't difficult either. So let's look at example 3 where they don't give us numbers and percentages, nor do they give us a table. They actually give us a scenario with the little picture. I like the picture. All right, so a spinner is spun around a circle that is divided up into 8 equally sized sectors. So, and they want us to find A, B, and C here. And look at our wheel off to the right, and those sectors are numbered 1 through 8, okay? So, let's take a look at A. Let's find the probability that we get a perfect square given it's even, okay? So perfect square given it's even. So we are given the evens to choose from. So what I'm going to do, my highlighter, I only get the evens to choose from. Which numbers are the evens? 2, 4, 6, 8. I don't care about any other number. So I don't care about this, blah, 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 blah. I am only given the evens to choose from. So right now, the numbers I have that are even are 2, 4, 6, and 8. I get to choose out of 4 possible numbers, right? So out of my 4 evens to get to choose from, which ones are perfect squares? 4 is the only perfect square, right? If I look at my list here, out of these 4 numbers, there is only one that's a perfect square, 1 out of 4. So this is the number 4, okay? And these are the numbers 2, 4, 6, 8. So out of the numbers 2, 4, 6, 8, we have one option, number 4. So 1 out of my 4. There you go. 0.25 if you want that in decimal. All right? Simple. Let's erase this because we're probably going to have to do something different now. The probability that it is odd given its prime. Okay? We are given prime. I want to only know The prime numbers. 2 is prime. 3 is prime. 5 is prime. 7 is prime. I don't want to know, thinking nothing about nothing else. 1, 8, 4, and 6 are not prime. So out of those 4 numbers I got to pick from, okay? They're the numbers 2, 3, 5, and 7. So out of these 4, I get to pick from. How many of those are indeed odd? 3 is odd. 5 is odd, and 7. 3 of those 4. So 3, 5, and 7. 3 out of 4. Okay, so 3, 5, and 7. We have 3 numbers out of my 4 to choose from. 3 out of 4. All right? Not too shabby. Okay, I'm feeling good with this. It's making sense. There's common sense involved here if you understand what given means. Last but not least, what is more likely? That's what we need to answer. You better answer that question. Okay? What is more likely? Getting a multiple of 4 given we spun an even, or getting an odd given that we spun a number greater than 2. Okay? And it says support your answer. The support your answer is the math. The math is a support. Acknowledging this is the answer. Okay? So let's make sure we answer what is more likely. How do we figure out what is more likely? Okay? We are going to do these 2 scenarios. I highlighted one in yellow and I highlighted one in blue. So we're going to have 2 probabilities. The number, okay, the situation that has the greater probability, the probability that is the higher number is more likely. I'm going to see the movies tonight, okay? What is the probability I see Endgame, Avengers Endgame, or what's the probability I see Sonic the Hedgehog, all right, which, by the way, my daughter wants to go see and it's not out yet, okay? Let's say there's an 80% chance I see Avengers Endgame, and there's a 20% chance I see Sonic. Obviously, it's more likely that I'm going to Avengers Endgame because that probability is bigger. So we need to find both these probabilities and see which one's bigger. Okay? So let's start. Let us start. Multiple of 4, given we spun an even number. Okay, well, this even thing is familiar. Even number, we are given the evens. All right, so let me write this down here. So the probability that we have a multiple of 4, I'm going to call that M4. That's multiple of 4. Given even number. So we get to just choose out of our evens. All right, boom. There you go. Again, weird. Man, you know, this isn't even in the same room with the other one that has the stroke and seizure. Oh, this technology is going nuts. Okay, highlighter. Even numbers, 2, 4, 6, 8. Nothing else matters. Okay, bang, bang. I have 4 things to choose from. So right now, out of my 4, which ones are multiples of 4? Okay, so even we have 4 options. 2, 4, 6, 8. Which one of those are multiples of 4? Well, multiples of 4 are counting by 4. 4, 8, 12, 16, 20, and so forth. So what numbers are multiples of 4? 4 and 8 are. So 2 out of my 4, 0.50. There's a 50% chance. The probability is 0.50 that if I spin this and land on even, that it's a multiple of 4. Now, let's do the probability that we get an odd given a number greater than 2. Okay, this is greater than 2. O is for odd. All right, so let's take a look at all the numbers that are greater than 2 on our wheel here. Okay, 1 and 2 aren't bigger than 2, but 3, 4, 5, 6, 7, 8. Those are all bigger than 2. I don't care nothing about these. Okay, gone, like they don't even exist. So out of all the numbers greater than 2, and there are 6 of them there, okay, So the numbers greater than 2, there are 6. 3, 4, 5, 6, 7, and 8. Out of those 6, which ones are odd? Okay. Well, again, what just happened? What is filth and flarn and filth? 3 is odd. 5 is odd. 7 is odd. 3 out of those 6 numbers that are greater than 2 are odd. That is also 0.50. Uh-oh. Did we just make a dookie in the pants? Because there's the boo-boo here. Is there a boo-boo? You tell me. If I had to answer this question, which one of these is more likely? Visca, they're the same. I had a student tell me, I think you made a mistake. There's a mistake on this one. I'm like, the mistake is the question you're asking me, punk. No, I didn't say that. I thought that, but I didn't say that. Okay, that shows restraint on my behalf, which I'm quite proud of. Now, 0.50 equals 0.50. So which one's more likely? There are 2 ways to answer this. Neither of them are more likely, or what I like to say, because I see that they're equal. And by the way, neither are more likely because they're equal is a fine answer. I like to say, what do they ask us? What is more likely? They are both equally likely to happen because they are the same. Their probabilities are equal, so they are equally likely. Meaning that Avengers Endgame versus Sonic. If I had a 50% chance of going to see Endgame, and I had a 50% chance of seeing Sonic, so which one are you more likely to see? Well, I'm equally likely to see either one of them because the odds are the same. They're both equally likely. And I'm just going to put to happen because I like that. And we're done. Oh my God. Do you know what that means? We only have one more lesson before the year's over. But you know what? Don't let me get ahead of myself. This is lesson 2. Oh my God, we got to do lesson 3 and 4. I lied. Oh, that's awkward. Anyways, yeah, we have 2 more lessons. I thought it was 1. But first, we got to do part 2 of this. Man, we got like months. Don't worry about it, kids. We have months. All right. Hey, look it. I will see you for Unit 5, Lesson 2, Part 2. And if you're just watching these back to back, for me, that might be a day or 2. But for you, that might be a second or 2. I'll see you.